Welcome back from your coffee break. My name is Peter Stoß. In English, I'm usually called Peter, just Peter. So I'm the diagnostic specialist, RA Consulting. I'm involved in OBD since over 30 years. And I'm the father of DiagRA and Silver Scan tool. So it's not a big surprise what I'm going to talk about. It's, of course, DiagRA and Silver Scan tool. I have not planned to make a complete presentation from DiagRA or Silver Scan tool. I think most of you know the tools anyway. I just have chosen some topics what is worth to talk about. And I'm going to start. So, you know, in DiagRA we have three main functionalities. One, we call it workshop diagnostics. It's everything that has to do with UDS and UDS protocol and ODX data. The next one, this is my favorite topic anyway. This is not a surprise. It's the OBD scan tool, anything with a standardized OBD for trucks and passenger cars. So, and finally, we have the so-called developer functions. These are the functions, additional pages we get after loading an A2L file. There's nothing to talk about today in this presentation because this functionality is stable and we are more focused on workshop diagnostics and, of course, especially on OBD. Besides that, we have some interesting topics. This is recordings of data stream parameters, snapshots, remote control by web services, and some tools and utilities around our diagnostic tools. And finally, my last part will be the ECU simulation, a tool we use quite often. So I jump directly into a special function of DiagRA. This is called, we call it send diagnostic services. Okay, DiagRA, Silver Scan tool, they send diagnostic services all the time anyway. So what is this used for, this function? The diagnostic services that are sent and received during normal communication are usually invisible to the user. It happens in the background, you just see the results, the data that are presented. But sometimes you are in need of to test something, to test a special diagnostic services that is not covered by the data in the background. So a special diagnostic service or a sequence of diagnostic service, and you want to have a complete control over that, so you do it low level on hex-based. And this is the use case for this function. We have, this is not a new one, but it's completely redesigned. It's up to date along the latest releases of the standards, UDS standard, the ISO 14229, and the old keyword 2000, ISO 14230, and of course, OBD J1979. Everything is up to date and completely covered, the complete standards. And what is now new, really new, is we have the standardized data objects are now included in our database in the background. So you can, for example, you can see that here, some of the identifiers select directly by name. For example, the active diagnostic session. So I have another example for that. It's from OBD J1979. It's service 1, mode 1, and 3 pits added. This is also something that is not done by DiagRA or Silver Scan tool. These tools usually request only 1 pit at the same time. We have now a request of 3 pits. So this is something that can be tested. And if you activate this function, these services you have configured will be just inserted in the normal communication, and you will see your results of your diagnostic service you have sent. This is, for example, here, service 19, so reading DTCs. There are no DTC stored. The next one is reading the VIN. We have some default default response of the ECU. And finally, the mode 1 and 3 pits, and we see, okay, this ECU, this was really an ECU and quite an old one. And it returned the results of the 3 pits properly as expected. So on this slide, I have put together some topics. I have not created a special screenshots for that, but it was worth to mention it. The UDS protocol on DuIP is available since a couple of years, but we have now made an own implementation, so it's really integrated into DiagRA. And we have the first version running of DuIP version 6, but we have never seen an ECU, so it's not deeply tested. Unfortunately, we didn't have the chance to get an ECU for DuIP version 6, but it should run, we expect it to run. So CanFD, UDS on CanFD is also supported since a couple of years. It's really stable, nothing happens, but it's adapted to additional interfaces, for example, interfaces from XAD. We have integrated the new VCI 4, version 4 is that from the API from XAD. The web services for remote control is really a very important addition plug-in of DiagRA and Silverscan tool. It's very often used in test benches and test automation, and it's very often used, and therefore we have quite a lot of requests for new functions in web services. So this is completely permanently maintained, this remote control API. And so we have many extensions. Just look into this. And if you are in need of something else, let us know. Besides that, we have an output of measured values by CAN. It sounds a bit crazy because all the data are requested by CAN anyway, but it's possible after we have received the data stream, we can create an output of these data once more on a CAN channel and create a DBC file. So the reason for that is some dynos are not able to use a web service API, but they are able to read CAN signals, raw CAN signals, and usually they can use ASAP3, but for data stream, this was quite a good option to transmit data to a dyno or to a test bench. Besides that, we have made many improvements in the user interface to keep it just up to date. We have added table views for OBD. We have a new data set selection for DiagRA. We have updated the selection box for data stream parameters and so on. So you will see that the user interface is permanently up to date. That's updated. And beside that, we have a new parser for DBC files. This was needed because of CanFD, to support CanFD. And by the way, it's the same one that we use in DiagRA. And the E2L parser is also the same that is used in DiagRA. Okay, and finally, for FlexRay, the new file format from AutoSAR, ARXML, ARXML for FlexRay is supported to configure the FlexRay bus if you use that for diagnostics. So I go to my next slide. It's a test cycle assistant, or often called a drive cycle assistant. We have several drive cycles in the background. This is a well-known one. It's the FTP 75, very old test cycle. You can run it like on your dyno. It's the same functionality as a drive cycle assistance on a dyno. But we have added something. It's the source. For the test cycle assistant, of course, we need the vehicle speed, and the vehicle speed can be retrieved by any protocol, all the OBD protocols. We have pre-selected the DIDs or PIDs or SPNs for the diagnostic protocols. For UDS, this is customer specific, of course. You can select your vehicle speed value from your ODX data. And what is now new is you can also use a CAN signal, a raw CAN signal, after you have loaded a DBC file. This is quite an interesting detail because we don't have to send requests to the ECU, so we don't create additional bus load. We can just listen to the CAN bus, and independent from the protocol that is used from the ECU. And this feature will be included in our next release of DiagRA D and next release of Silverscan 2 as well. So we have done quite a lot in recording data. This means continuously acquire data stream parameters or other values. So data that are quite often visualized in the graphical view. We have, as file format, we have since many years, we have the CSV files. This is well known, and they were often used to open it in Excel, to create an Excel sheet from that. But it's not very convenient and not such a powerful feature. We have only one timestamp in the first column, and all the data that are read out are in the following columns. And this is not very precise. The timestamp matches only to one column, of course. So we have the MDF format supported since a couple of years as well. But what is new, we have, it's permanently maintained and up to date. We have supported several standards, so you can, several versions of the standard, so you can select the version of your standard you want to use for the output file in case it uses a special tool to show the data. And we have, of course, supported all of them, even the latest one. This is for MDF. And what is, I have some supplemental slides for that. And something new is writing directly into Excel. I have some slides and screenshots for that as well. We'll look under that after that. The interesting thing is the file formats can be used simultaneously. You don't have to decide which one to use. You can use all of them if you want that. A detail for recordings, which is new. In the original version of DiagRA D, all the data from the currently selected mode in OBD mode were recorded to a file and all the ECUs. So if you had selected mode 1, we have recorded all values, all bits from mode 1 and from all ECUs in a file. Now you can select if you say, okay, engine control is pretty okay, I don't need the other ones. You can select one single ECU, and on the other hand, you can decide to record mode 1, 6, and 9 simultaneously in parallel. And all of the combinations are possible now. So, and finally, a small detail, but we had a lot of discussion over weeks about that. These are the timestamps used in our recording files, in all of them. The standard timestamp format is in milliseconds, and it starts with 0 at the beginning of the file, and we'll just get the distance to the beginning of the file. We had a so-called absolute timestamp, but the absolute timestamp was related to the start of Windows. It was not really an absolute timestamp. But now we have an absolute timestamp. It's a UTC, a standardized time format all over the world. So this makes it now possible to synchronize multiple recording files from different tools and put it together in one graphical view. This was not really possible before, but now it's possible even on different computers. If you have the same time base, you can put it together. Now we go through some detail slides. This is DiagRA X and the DiagRA X viewer. You have seen this already in Hannemann has mentioned it in this DiagRA X presentation, and Armin had a preview of DiagRA X viewer. This slide shows us how DiagRA Silver Scan tool works together with DiagRA X and the DiagRA X viewer. We can create MDF files. We can present it in the DiagRA X viewer. This tool is available since around a year on our download site, and it was a big surprise. We had so many downloads. It seems to be a helpful tool, and so we decided to improve it, to add new functionalities, to analyze the data. And this will be done in the next months and years to really enhance the DiagRA X viewer and to make it to an DiagRA X viewer Pro, the professional version. The standard version will be available for free on our download, even in the future. But we will have for the professional version, we have an additional fee, of course. So this is the same tool that is used from DiagRA X for MDF files. DiagRA X creates the same MDF files. What you can see also on the slide is how DiagRA D and DiagRA X work together, how it can be managed to transmit data from DiagRA D to DiagRA X. This is done by the CAN output I mentioned in my second slide. We can use virtual CAN channels. This is not really a hardware channel, it's just software, but it's a good method to transmit the data and to show them online live. So one example for diagnostic data in the DiagRA X viewer is the diagnostic test results, some results of mode 6. This is very good for presentation. We have the range, the upper limit and lower limit of the diagnostic test results. We have the test value itself, which is always in the range of the upper and lower limit. And we have the max value and mean value. This is the dotted line. You can see this is, yeah. And plans for one of the next releases is to add mode 3, 7, and A, so reading DTCs, to our MDF output, and to add a special view in DiagRA X viewer, so that you can see the event when the P-code was stored in ECU. So once more, recordings. This is very new and I like it, really. It's a new function that will be available in the next release of DiagRA D and Silver Scan tool. This is recording directly into Excel. So we said if the engineers use Excel anyway to import CSV files, why shouldn't we write directly into Excel? And this is done with this new feature, writing directly into Excel. And it's well arranged. We have all the header lines and the physical units and names and pits. And we have a timestamp for every value. So every value has its own timestamp. This is the same, of course, for a data stream. And this is very precise, much better than before. And on top, we have something like this. This is the graphical view automatically created out of the data. If you want to get just a quick result of your recording, you can use this. You can use it. You can save it in parallel beside MDF for a quick view. It's a nice new feature. So one more Excel. I know the engineers, they like Excel, and this is a tool. An additional tool is available on our website, on our download site also since quite a long time. We have a lot of downloads. It was inspired by an idea of a customer. This is not recording, but it's a snapshot, a one-shot readout of even the complete vehicle or the ECUs. It's put together in one XML output file, and this tool, the XML snapshot to Excel, imports a snapshot into an Excel sheet and writes the complete readout in one column. If you import a second snapshot and a third snapshot, this will create additional columns. So you can see all the data side by side, and it's easy to compare and to see what happens. This looks like this. I've chosen a readout from the ratio data, UMPR data, different readouts. The first one, I think it's pretty the same. The third one, the third column, is even taken from a diesel engine. So compression ignition, and the other ones are from spark ignition engines. You see, it's a different, the data on a different place inserted. And the last column is a different ECU, another vehicle. We have some more ratio groups included in the OMPI data, and you see everything is well aligned. So the tool is able to read, to import even snapshots from different vehicles with different data supported, and the data are always aligned, and you can compare pretty convenient all the data. So I have one more example. Once more, the test results. This is always nice to show. We have, once more, we have three values, minimum and maximum, and the test value. And this is even colored. The yellow ones are the ones that have not yet test results, and the green ones are the test results that are okay. And in case we had a failure, if a minimum or maximum value would have been exceeded, we would get a red colored entry. So next one. This is OBD. So now we are moving to OBD, my favorite topic. J1979. It's available since over 20 years in DiagRA and Silver Scan tool. This standard is very stable since many years. Nearly nothing changed in the basic standard for the diagnostic services. But of course, there are updates for the so-called digital annex. We have new PIDs, new info types, and new monitor IDs, especially mode 1 and mode 9 is permanently updated in the standard. And it's, of course, updated as well in our tools. We keep it always up to date as fast as possible. Besides that, we have some improvements in the user phase, as I already said. We have added some table views for mode 1, for example. We had table views already for mode 6, and we have added a table views for mode 9 to make it more convenient to the user. So, and this is one more feature that will be available in our next release. Is one more table view for mode 3, 7, and 8. It shows the three modes to read out DTCs on one table. And you have all the P codes stored in this ECU on one page. So one additional slide for Silver Scan tool. We have this is available only in Silver Scan tool. It's a graphical window to show the data on the mode 1, mode 6, and mode 9 data. We had this already supported with DiagRA M or MC in the past, but this product is discontinued. So we decided to develop a simple graphical view for our Silver Scan tool. if you want a bit more, or if you want to use something like this in DiagRA D, or you need a more enhanced function, you can use, of course, DiagRA X. And as I showed in my earlier slide. So, and this is a very important topic, that the new J1979-2, we have often been asked for that. Do you have a DiagRA D or SilverScan tool ready to use it? I was a member of the working group for J1979-2. It was released last year, I think in April. And I can say now we have the latest official release of DiagRA D and SilverScan tool has J1979-2 included. It's now available in the very first version. Even if we have never seen an ECU, everything we made is based on simulation data, on fake data, self-created data. So I can't guarantee for the result, but I would be happy to see any real-life data from an ECU. So if you have something, just let us know. So just a brief overview, what is new in J1979-2 and what is the same as before. So the first step was just to keep everything as it is, just to move to UDS. So all the modes, the 10 modes, are mapped to UDS services. So finally, for UDS services, all the data are mapped completely. Really, the digital annex is reused one-to-one in J1979-2. But we have some new requirements which were not present in J1979, new requirements from legislation. This is the DTC-specific data. Readiness, test results, and in-use monitor performance was always grouped in the past. So we had only readiness groups and IOPR groups that represented a couple of DTCs. So the new thing here is now that we have the same data for every DTC. So you have it completely in detail. This is, by the way, this is one of the reasons for our developer functions. The developer functions we had after loading an A2L file made exactly just this, to break down the readiness groups and test results and IOPR data to single DTCs. This is now will be available in the future in -2, and in addition, it's called supplemental monetary activity data. It's a mini denominator, mini numerator that is an additional function as well. So little overview. You know, we have the ISO 27145. It's well known by worldwide harmonized OBD. This is also OBD on UDS. And J1979-2, which is called OBD on UDS. And finally, I had a chance to look into the -3, which is an OBD on UDS for zero-emission vehicles, so especially for electric cars. These three standards are very similar. All of them are based on the same services and the same data, digital annex. And it's a very brief comparison, not in detail, but these are the things I thought are important to compare. So besides data stream and the services, we have reading DTCs. This is quite different. The requirements in Europe for Euro 6 is the fault classes A, B1, B2, and C. So the fault classification along the fault severity. This is not used in North America or for zero-emission vehicles. The permanent DTCs are not supported in the ISO standard, but it's supported in the -2. It's not used in the -3. The readiness test results and IOPR data, as I already said, is still grouped in the ISO standard, but it's DTC specific in the -2 standard. The routines are supported, and the transport layer is the same. It's CAN Classic, no CAN FD, and DOIP is allowed as well, but I've never seen it up to now used. So from my point of view, the big difference for tool developer, tool supplier is the fault classification for Euro 6 and by the way for China 6 as well, and the DTC specific data in the J1979-2, which this makes a big difference in the tool. So how does it look like? We have used the same user interface as already used for the ISO standard, for the ISO 27145. Right now it's no difference. It's everything is done just by read out the support information. So you don't have to make a different selection to use one of the 3 standards. Just say I want to use OBD and UDS, and everything is done in the background automatically. These are data stream parameters. This is how it looks like now for readiness groups. We have still readiness groups, but we have 20 readiness groups. But the readiness is available for every DTC, so it's grouped in this view. Of course, there are some enhancements possible, but right now we focused on the data acquisition. It's possible to all the data and services are supported, and everything is able to read out. And once we have real life data from ECUs, we will work on the user interface and do some improvements right there. One more view on the IOBR data. The result is quite the same. So it's still numerator, denominator, and the calculated ratio, which we have added, which is calculated by ourselves. But the data reported are the same. So let's go to J1939. This is a very important protocol for us in the last years. This was not expected in that way. It's used from the truck industry and off-road vehicles and machinery. It's used everywhere, all over the world, but it's very important, I think, especially in the US. The J1939. But this is not just a simple protocol. It's a crazy thing, I would say. It's not one standard. It's, I don't know, I think 30 substandards or even more. I didn't count them. Thousands of pages. And if you work with J1939, you will have a surprise every day. You will see everything, something that we have never seen before. So it's a big challenge. We need a lot of time for maintenance, for updating. We are still making up improvements on the communication layer and data handling. But I would say it's really stable. We have now a couple of years experience with the J1939. We have seen a lot of crazy things, and it's getting better and better. For the digital annex, which includes the ESPNs and the PGNs, so all the data that are transmitted, the data description, we have around 4 updates per year. I've looked at the last years. We have 3 to 5 updates per year, so in average 4 updates per year, and every time we have some 100 new SPNs and PGNs. So it's a very dynamic, the standard, and we have to do quite a lot with maintenance. But it's interesting. It's interesting for an engineer. You have a lot to think about it. So it makes fun. The J1939 was a chance, an opportunity to get into a new project. We call it a Silver Snap tool. So Silver Scan tool is a subset of DiagRA D. It's the OBD subset. Silver Snap tool is another subset of Silver Scan tool. It's OBD only for heavy duty. It's based on SilverScan tool, but it has removed everything that we don't need for this project. I would say it's a readout, a snapshot tool only for J1939 and J1979. What is new is this little dialog box for, I would say, a one button application to start a snapshot. What is really new is the data handling after that, after acquiring the data. Because the collected data are encrypted before they are saved to the disk, and they are transmitted to a backend server. Next slide, I want to show you how this works. So on the left top, we have a truck and the truck owner. The truck, of course, has some data available. On the left bottom, we have SilverSnap tool that is able to read out the data from the truck before it is saved to the to the disk. It is encrypted, saved to the disk, of course. Some metadata are added to this package, and it's transmitted to a server, which is our own. It's a RA server, so the tool, OBD Snap tool, has all the data to get connected to the server. SilverSnap tool has not the information to connect directly to the backend server. This data package is verified if it is okay. It's not opened, of course. I am not able to open it, but we check if it's is something else. Really, data after verification, it is signed. We get connected to the backend server, transmit the data, and after that, so the backend server is able to decrypt the data, to read them. And finally, the truck owner gets an email, your data have been transmitted successfully to the backend server. This is a very interesting project, a very exciting project. I don't want to talk about the background, but I'm pretty sure you will hear about that in the future. So this is my last topic, and it seems to me that I'm quite good in time with my presentation. So something completely different. Once more, I've shown this already in previous user days, but it's once more very important. Over 10 years ago, we decided we should have a simulation tool to simulate ECU data and to simulate interfaces. It's not so easy to get access to every ECU, and sometimes we have a customer request, please help us, and please help us pretty soon, immediately. I have some trace files from my communication, can you please check this? And so we decided to develop a simulation tool based on the data, the pre-recorded data of vehicles or ECUs, and simulated using standardized interface interfaces. So the interfaces are pass-through J2534, which is very often used for OBD. This is RP1210. This comes from the truck industry. It's used for simulation of as an interface API for J1939. And finally, the DPDU API. This is another standard for interfaces used together with the so-called MVCI server. The MVCI server is a diagnostic runtime running on ODX data. And this is the standard interface used in an MVCI server. So what does this mean? We have a simulation of both, a software simulation of both the ECU and the interface. There's really no hardware, but it's a real-time simulation. So the diagnostic tester or whatever it is not aware that there is no interface and vehicle in the background. It looks exactly the same. So the simulation tool is not especially not only useful for DiagRA or Silver Scan tool. It's a standard simulation, so it can be used from any tool, from any tester tool that uses one of these APIs from pass-through RP1210 or DPDU API. So in our database, the tool itself, the simulation tool, supports all the protocols, even very old protocols like J1850 and K-line, or the CAN-FD and DoIP. But anyway, there's not really one of these physical layers in the background. It's software only, but it looks like this. So we have, on the left side, we have the database. It's an XML file, the project file that includes all the data to be simulated and all the ECUs. On the top, we have DiagRA S. This is, S stands for simulation. This is the user interface of DiagRA S. Then the bottom, it's the server. This is the simulator of the CAN player of the data. And this can be used also without user interface. This is something we use ourselves for testing. This pass-through server supports the DLLs, the interface APIs, and so we can get access to the data. This is very helpful. We have been asked for that several times. We have spent a lot of time, a lot of effort the last 2 years to enhance this tool. So it's really, we bring it forward, and this was the reason to show it to you once more, how we work with that, what is, how we can manage to analyze data sometimes so quickly. Okay, little addition to that, as I said, PDU API is supported and DoIP is supported. DPDU API is a wrapper around the other two DLLs, pass-through and RP1210. And it's also the API that gives us access to DoIP. So this is my last slide. It shows one page of the data manager of DiagRA S. The data, the project can be created by importing a log file or trace file, a pre-recorded log file from DiagRA or Silver Scan tool. And you see, this is an example from J1939. We have several ECUs visible in green, and we have a diagnostic message. It's DM1 and then DM25, DM24, DM5 and DM24, and some PGNs. So just everything that was included in the log.